Okay, we're going to learn about transformations of graphs of functions. And there are two types of transformations. One is rigid and the other is non-rigid. Now, rigid transformations don't change the shape of the graph. They just move it around. Okay? And so the first thing we're going to look at are vertical and horizontal shifts. To start, let's look at the graph of the absolute value of x. So we have a vertex here at the origin, and this is a ray going up with a slope of 1, and this is a ray going up with a slope of -1. So the question is, what would happen if we added a constant to the graph of f of x? And so I've graphed this absolute value of x on Desmos, and you'll notice that I've added b, and if we get the absolute value of x plus 1, it goes up 1, plus 2 goes up 2. So if I add constants to the absolute value, it goes up. And if I subtract numbers from the function, it drops down. So that's called a vertical shift. Notice that the shape does not change at all. It just picks it up and moves it vertically. So what would happen if instead of adding a constant to the function, we added a constant to x? So now I've got f of x equals x plus b, and the b is being added to x. It's inside the absolute value function. So watch what happens. If I add a positive, it goes the opposite way you might think. It goes to the left. Okay, so x plus 5 moves our absolute value graph to the left 5 units, and then x minus a number moves it to the right. So here's a summary of what we've learned. Adding a constant c to a function moves the graph up c units. So if you add it to the entire function, it goes up. If you subtract from the entire function, it moves down. Okay, adding a constant c to x moves the graph to the left c units, and subtracting a constant c from x moves the graph to the right c units. So let's take what we've learned and transform this graph f of x equals x minus 3 squared minus 2. Now, the standard parent function is f of x equals x squared. So that's a parabola, 0.11, 0.24, 0.39, and then the same over here. So I've got -2.4 and -3.9. So this is f of x equals x squared. Now we're going to transform it. Since I'm subtracting 3 from x, that means I'm going to move it to the right 3 units. So I'm going to go 1, 2, 3. And since I'm subtracting 2 from the whole function, I'm going to drop down 2 units. So you could think of this as shifting my axes to the right 3 and down 2. And now I can just place my transformed graph, same shape. Okay, 1, 1, over 2, up 4, 1, 2, 3, 4, over 3, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the same thing over here. Let's see, I need to go over there, right? And here's what it looks like. So that parabola has shifted over 3, down 2. Same shape. Another type of rigid transformation is a reflection. So what would happen to the graph of y equals the absolute value of x if we made it negative? So let's graph absolute value of x. Looks like this, right? And it goes up like that. Okay, so if I make the entire function negative, what's going to happen is it's going to change the sign of every y value. Instead of being positive y values like we have here, they're all going to become negative. So 0, 0 is going to stay the same, but 1, 1 will become 1, -1. 2, 2 will become 2, -2, and so on and so on. And so what happens is it is reflected over the x-axis. So if I make the entire function negative, it flips it over the x-axis. What if we just make all the x's in the function negative? Well, okay, let's graph y equals the square root of x. There's a point 0, 0, 1, 1, 4, 2, 9, 3, and we get this square root function looking like that. Okay, now what this is saying is all the x's that were positive now change sign and they become negative. So 0, 0 stay the same, but now I'm going to go to negative 1, 1, negative 4, 2, and negative 9, 3. And so this is reflected over the y-axis. Okay, so changing the signs of all the x terms in a function reflects it over the y-axis. So to summarize, changing the sign of the entire function reflects the graph over the x-axis, while changing the sign of x reflects the graph over the y-axis. Now let's look at what we call non-rigid transformations, and these transformations actually change the shape of the graph. And we're going to compare the graphs of absolute value of x to y equals 3 times the absolute value of x and y equals 1/2 times the absolute value of x. So here's our familiar f of x equals the absolute value of x with the vertex at 0, 0, and it's going through 1, 1, 2, 2, 3, 3, and so on. Now, what would happen if we tripled that? Okay, well, let's take a look. They both share the point 0, 0, but look what happens to the y-coordinates. So I've got a point here at 1, 1, and on the 3 times absolute value of x graph, it jumps up to 1, 3. And this point here at 2, 2, it jumps up to 2, 6. So you notice the pattern? If I multiply everything by 3, I am tripling the y-coordinates. Okay, so now that you kind of know the secret, you can guess what's going to happen if we multiply everything by 1/2 times the absolute value of x. Now all my y-coordinates are half of what they normally are. So instead of being at 1, 1, it's 1, 1/2. Instead of being at 2, 2, it's at 2, 1. And instead of being at 4, 4, it's now at 4, 2. To summarize this kind of transformation, multiplying a function by a constant whose absolute value is greater than 1, that will stretch the graph vertically, and multiplying a function by a constant whose absolute value is less than 1, like 1/2 or 2/3 or 0.8, that will compress the graph vertically. So let's take what we've learned and apply it to some examples. So here's just a random function graph, okay? And we want to take this y equals f of x and do y equals negative f of x. So remember, that's going to reflect it over the x-axis. So anything that was below the x-axis now comes up above. Whoop. And anything that was above will come down below, and so on. And so on. I'm going to connect them. And this is y equals negative f of x. Okay, so let's look at what happens if we make x negative. So remember, this is going to reflect it over the y-axis. So this point here is at negative 3, negative 2. It's going to move over to positive 3, negative 2. This point is going to stay on the y-axis, so it's going to stay there at 0, 0. This point here is at 4, negative 1. It will now go over to 4, negative 1. And finally, this point here is at 5, positive 1. It will now go to negative 5, positive 1. And so when I connect the dots, you can see that this function has now been reflected around the y-axis. What happens if we multiply our function by 2? That means we're going to double every y-coordinate. So this point is at negative 3, negative 2. It will now go to negative 3, negative 4. This point is at 0, 3. It will now go to 0, 6. This point here is at 3, let's see, 1, 2, yeah, 3, negative 1. It'll go to 3, negative 2. And this point is at 5, 1. It will now go to 5, 2. Every y-coordinate is doubled, which means our graph is stretched vertically by a factor of 2. And finally, how about if we subtract 2 from x and add 1 to the whole function? Well, remember that subtracting a number from x will move it to the right that many units, and adding a number to the whole function will move it up that many units. So we're going to go to the right 2 and up 1. So here's my new origin. Okay, and this point here will go to the right 2, up 1. This point here will go to the right 2, up 1. This point down here will go to the right 2, up 1. And this point will go to the right 2, up 1. And so our transformed graph looks like this. Notice that the shape does not change. That's a rigid transformation.